Okay, we're back again with part 2 of topic 8.11, volume with moisture method revolving around the x or y-axis. This time we're going to do some examples using the washer method to revolve around the x-axis. We'll start with this exercise here where we have let R be the region bound by the curves f of x equals 3x plus 1 and g of x equals 4 to the x in the first quadrant. Find the volume of the solid generated by revolving R around the x-axis. I'm going to start by graphing this so that I can see the math. See the math, you can do the math. If we graph g of x equals 4 to the x and f of x equals 3x plus 1, those are supposed to intersect on the y-axis because when I plug in 0 to both of them, I get 1. Y equals 1 there. And then they'll intersect here where x equals 1 because when I plug in 1 to both of them, y equals 4. And so the region that I'm looking for, this is R. So inside R, I'm going to draw one rectangle. As a matter of fact, I'm going to do the big rectangle from f of x because I'm going to do this by generating one large outside disk, and then I'm going to subtract from that the smaller inside disk. So to start with, we're going to have that outside disk. And that is going to be height, f of x, and width, dx. So the dimensions of this, when I revolve it around the x-axis to get my disk, the radius is going to be f of x. So to get the volume of one of those disks, the big disk, I'm going to have pi times the radius squared times dx. So to get the volume of all of them, I'm going to integrate from 0 to 1, my x's, pi on the outside because it's a constant multiple, and f of x is 3x plus 1 squared times dx. And that will give me the volume of all of those, that is the large solid revolving the curve f of x around the x-axis. But I have to subtract from that the volume of one of the smaller inside disks. So one of the smaller inside disks is going to be made up of these rectangles. I'm going to erase that black rectangle now. Whoops. I'm going to cut out this rectangle. And this time, the lower curve here is g of x. So this disk, the radius is going to be g of x. And the width is going to be dx. So the volume of one of these is going to be pi times g of x squared times dx. And so the volume of the entire region that I'm taking out there, the solid that I'm taking out, is pi integrated from 0 to 1 of 4 to the x squared, which is 4 to the 2, well, 4 to the 2x dx. And so what I'll do is integrate, or take the large volume minus the small volume to get the region, or to get this volume of the solid. So my answer, the volume of this solid, is equal to pi times the integral from 0 to 1 of 3x plus 1 squared dx minus pi times the integral from 0 to 1 of 4 to the 2x dx. Or if you like doing the integral of the formula, you can just say that's equal to pi times the integral from 0 to 1 of the top function, 3x plus 1 squared, minus the bottom function, 4 to the 2x. Oops, we already squared it, sorry. 4 to the x squared is 4 to the 2x. All times dx. Personally, I prefer to think through the geometry like we did up here. And a lot of times you're going to be asked just in FRQ to set up the integral and not evaluate on a non-calculator part. If you do have your calculator, you can set it up. Either way, one of these two ways will work for you. I'm going to put it in the first way. I already have it in, except for I messed up my limits of integration a few moments ago. So I just get to copy and paste it in. And I didn't multiply by pi yet, so I'm going to multiply my answer times pi. And I get the volume of that solid is about 4.994 or 4.995. If you chop, it's 4.994. If you round, it's 4.995. And then that's going to be units cubed because we're doing volume. Let's do another example. Let's look at one where we have R as the region bounded by the curves f of x equals x to the fourth and g of x equals 8x. We're going to find the volume of a solid generated by revolving R around the x-axis. Like always, we will start by sketching the curve. F of x equals x to the fourth. It's going to look something like a parabola. And g of x is 8x. That's going to be a line through the origin. If x equals 2, then f of x equals 16 and g of x equals 16. So they intersect at x equals 2 and y equals 16. And at x equals 0, they intersect at the origin. And so we're going to revolve that around the x-axis. I'm going to draw one rectangle, but I'm going to do the large rectangle, and then we'll take out the smaller rectangle in a few moments. So we're going to generate this disk with width dx and radius. The blue line is g of x, so that's going to be 8x. And so the volume of one of these disks is going to be pi times the radius squared times dx. The volume of all of those disks integrated from 0 to 2 is going to be pi, bring out because it's a constant multiple. We could just leave the 8x in there squared times dx, or we could square it and do 64 on the outside times the integral of x squared dx. Either way is fine. But that's the volume of the large disk. Now we're going to erase that. And we're only going to, we're only going to do the the lower rectangles. So we've already done the larger rectangle. Now we're going to rotate this disk around and take out that inner part. I'm going to draw that over here. And the radius of that is going to be my g of x curve, or my x to the fourth. Height still dx. So the volume of one of these is going to equal pi times x to the fourth squared, which is just x to the eighth. We'll do that in a minute, times dx. So if I want the volume of all of them, I'm going to get pi times the integral from 0 to 2 of x to the 8th dx. Now that's the volume of the inside part I have to take out. So now to get the volume of the region revolved around the x-axis, I do pi times the integral of 0 to 2 of 8x squared, the large region, dx, minus pi times the integral from 0 to 2 of the smaller region, x to the 8th dx. Or you could use the formula and say that's pi times the integral from 0 to 2 of the upper curve is the 8x all squared minus the lower curve, which is the x to the 4th all squared, or x to the 8th, you could have written in there. All that times dx. Either way, it's going to give you the same function. So I'm going to do this as pi. Well, we'll just do the integrals first, then we'll multiply by pi. So if I do the integral, I'm doing the two different integrals just because it's easier to do that in the calculator. So it's math 9, integral from 0 to 2. And then here I'm going to do 64x squared, because that is 8x all squared, times dx. And then minus the integral, math 9, from 0 to 2 of x to the 8th, since that's x to the 4th square, with respect to x. When I do those integrals, then I'm going to multiply everything by pi. Seems a little large, but I get 357.443. And that's units cubed. If you're given units, you have to put units on there. But that's how you do examples where we're revolving using the washer method around the x-axis.